This is pre-AP Calculus. We're looking at note 7.5, graphing exponential functions. We are getting to be a little more specific instead of big generalizations. So exponential growth functions. So consider this function here where the base is 2 and there is no transformations whatsoever. Let's start here with 0. If we put 0 in for this, 2 to the 0 is going to be 1. So that would be the ordered pair 0, 1. It will go right here on the graph. Let's say we put this 1 in. That would be 2 to the first. 2 to the first is 2. So from the origin, we go right 1 and up 2. Say we put a 2 in. 2 squared. 2 squared is 4. So from the origin, we go to the right 2 and up 4. Hopefully you're seeing a pattern here. If we put negative 1 in, 2 to the negative 1 is the same as if you reciprocate the 2, 1/2, change the sign of the exponent. That's the same as 1/2. So the ordered pair, negative 1, 1/2. Put negative 2 into the function 2 to the x. So make sure this is clear. This is 2 to the x. We're going to have 2 to the negative 2. If you want your base, if you want your exponent to be positive, reciprocate your base. And then 1/2 times 1/2 is 1/4. So check this out. As we increase the numbers by 1, our y values are doubling. If we decrease the x values by 1, our y values are being cut in half. So if you took this original point right here, 0, 1, it is 1 above. I should have done this at the beginning. This horizontal asymptote we know is at 0 because the constant in this is 0. It's 2x plus 0. Our exponential function is growing towards or away from that horizontal asymptote. So the magic point for this is 0, 1. I'm using the word magic pretty loosely here. This is our most important point. Once we have that graphed, we use our base to find other points. So this is assuming that there's no horizontal dilation, which I don't think we'll have any of those this year. Assuming there's no horizontal dilation, once you have your magic point, 0, 1, you go to the right one. Since our base is 2, we double it. So instead of going up 1, we go 2. Go to the right one, double 2, we go up 4. Go to the right one more, you're going to go up 8. Go to the right one more, you're going to go up 16. As we move left, we're going to cut it in half. 1 cut in half is 1/2. Half cut in half is 1/4. 1/4 cut in half is an 1/8 and a 16th and a 32nd. This is the process that we're going to use to graph exponential functions. Let's check it out. Let's look at one that's a little more complicated. Not much, but a little bit. So this is going to be an exponential decay function. You can tell that because it says that. But we're supposed to graph the function f of x equals 1/2 to the x. We don't like our base to be less than 1. So we're going to reciprocate it and make it a 2. Change the sign of the exponent. So the only thing that's happening here, I didn't mean to circle that. The only thing that's happening here is this is going to have a horizontal reflection. It has a horizontal reflection because we are multiplying the inside by a negative number. So if we just go back and look at this graph, a horizontal reflection is going to look something like this. This is how the new graph is going to look. So this graph here was reflected horizontally about that vertical axis. But check out, if we follow these red steps, which I don't believe are on your notes, if this is 2020 for you, because I changed the notes just a few minutes ago. 1, find the location of the asymptote giving justification. This is the process that I think you should go through to graph this. So the constant, f of x has a constant of 0. Therefore, there's a horizontal asymptote at y equals 0. That is the x-axis. Two, state if the graph is above or below the horizontal asymptote giving justification. Well, a is bigger than 0. Therefore, f of x is above the horizontal asymptote. I'm just going to take this a step further, and I'm just going to write on my graph that I know it's going to be above. That way, when I get to my actual graph, I know that I have to graph everything up here and nothing down here. 3, identify if the graph is growing towards or away from the horizontal asymptote, giving justification. I forget the letter we use for this. I think we used the letter C. Let me check real quick my notes. Yeah, C. C, which is what we're multiplying by the inside function, is less than 0. Anytime that happens, f of x grows towards the horizontal asymptote. So I'm just going to write the word towards over here on the right. As we go right, our graph should be getting closer to the horizontal asymptote. 4, use a coordinate rule to find the new location for 0, 1 on the graph as a starting point. Well, what is the coordinate rule? Well, the coordinate rule is we are supposed to change the sign of everything on the inside. So the original ordered pair, if it was x, y, our new ordered pairs, we change the sign of x. Nothing's happening on the outside of the function, so y stays the same. That's our coordinate rule. We're going to find the new location of 0, 1. So if I take 0, 1, and I apply this coordinate rule, I change the sign of 0. Well, that's still 0. And 1 stays the same. So my new ordered pair is 0, 1. You're thinking, well, that's not any different. Well, you're right, it isn't. Because if I had this point 0, 1 and it's on the line of reflection, it's not going to go anywhere when we reflect it. It's going to be in the same location. 5, use the base to find other points. Our base, there's not any work to show for this. Our base is 2. Once we wrote it with b being bigger than 1. So as we go to the right, we're supposed to go up 2, since we went up 1, and then 4, and then 8, etc. But if you look here, it says we're supposed to grow towards the horizontal asymptote. So that means as we are going to the left, we are doubling. So left 2, up 4. There's no space to put the 8 on there. As I go to the right, it's getting cut in half each time. Half of 1 is a half. Half of a half is a fourth. Half of a fourth is an eighth. So my curve is going to look something like this. So it fits my description. It's above the horizontal asymptote. As it goes to the right, it's growing towards. Hopefully you can see if I were to just take this and throw this up here. This is the same graph. Just wanting to snap to the grid. Reflected, it's a horizontal reflection reflected across the y-axis. All right, I guess we're going to stop right there with the video. That's just an introduction of how this is going to work. We will get into a little more complicated problems in the next video.